Assalamu alaikum. This is Dr. Usman Sadiq Brancha, and we would be having our lecture number 15 of the subject Applied Quantitative Analysis and Practices. Previously, we were having a discussion on what were the main steps involved in testing of hypothesis, and there were totally 6 steps which we discussed in detail. And how to basically formulate null hypothesis and alternative hypothesis, and then how to basically state it in mathematical form, and then after that how to determine the test statistic and whether the details are available or not, whether we are given standard deviation or any other property of the population or not, whether and then we have to determine the critical values, because we have to determine first the test statistic which is to be applied based on the information which is given to us, and then we have to determine based on the test statistic whether which critical values would be of importance to us. So likewise, then again we have to determine the level of significance as well in that case, and afterwards then we have to go ahead with our calculation part, where we have to calculate the z statistic or t statistic or whatever the test we have to perform. And then we have to compare it basically whether we have basically these values conform to the standards or not, and based on that then we have to accept or we have to reject the hypothesis. Basically, based on this acceptance or rejection of hypothesis, then we have to draw our managerial conclusions. So this is very important, that when we are stating a statistical model, we have to then test our observation or convert our observation to the hypothesis part, so that more tangible formal way of testing our assumptions is made. Then afterwards we went through a testing example in which we took a technical example of hypothesis, and we applied z-test in this case. Afterwards, performing z-test, then we had another method regarding how to test this hypothesis with p-value, because p-value again is a probability factor which tells us whether that specific test result would be credible enough for other samples or not. So based on this p-value, again we would be testing our hypothesis and we would be rejecting it or accepting it. Afterwards then we went through our another hypothesis example, and in which basically we were not given the standard deviation of population, and then we applied the t-test in that case. Normally in realistic sense we don't have any information of the population, whether it's the standard deviation or whether it's mean, so that's why normally t-test is followed for hypothesis testing. So this was related to our testing of a hypothesis, which we basically did in previous lecture. So now after we have discussed about these hypothesis testing phenomena, it is important to note that this phenomena of hypothesis testing cannot be commenced without first ensuring that the data set which is given to us satisfies certain conditions, and these conditions are very vital for our further hypothesis testing in this case. So in order to have a look at these conditions, we have to basically go through certain assumptions. As you can see here, that basically the test based on this normal distribution, they have to meet the condition of the linearity or additivity, then normality and homogeneity of variance, and then independence of variables, basically in this case. So these four conditions are of very much importance, because any condition which is not satisfied would affect our hypothesis testing, and then we would be ending up in the wrong conclusion in this case. So coming to the details here, first part is related to the additivity and linearity. Now here basically the outcome variable should be linear as compared to the individual independent variable. And basically, in case you have several independent variables and dependent variable, then you have to find out their combined effect, and you have to ensure that there should be linearity in their combined effect as well. So basically, if this assumption is not met, then again that means that your model is not up to the task and it won't be valid enough. So basically we have to ensure first that each variable which is entered in the model, which we basically discussed previously, it should be linear in nature. So in order to have the linearity part, we would go through how to basically test it. However, the relevance of this normal distribution factor is that it is affecting the parameters or the variables which you are testing. Then the confidence intervals around that specific parameter are affected. Then there is also impact on the null hypothesis significance testing. So basically these three are very important factors, and any of these factors, if they are affected by the abnormality of your data, then definitely the end result or end hypothesis conclusion would be wrong. So basically that's why that this assumption of normal distribution is of equal importance before testing of hypothesis here. So here when do we have to test for this assumption of normality? In small samples, of course, we have to do this, but yes, it is stated that under central limit theorem, which we did discuss in previous lecture, that central limit theorem states that if the sample size is greater than 30, then under that theorem the normal distribution would automatically be followed in that sample. So in order to ensure normal distribution, normally sample size should be greater than 30, but in some nature of research the sample size is less than 30. So even in those small samples, then we have to ensure and we have to test whether the data nature is normal or not. However, though it is stated here that okay fine, central limit theorem allows us to forget about the assumption of normality, but in large samples as well we do have to test that, because it is not necessary that the sample would be exactly normally distributed. So still in this case the major reason why we should test for normality in central limit theorem, despite the fact the central limit theorem is saying that okay fine, the distribution will be normal. The reason being so is that larger is the sample, then our concern is shifted to the outliers or the abnormal values, because any extreme abnormal values in even those large samples would affect your result. So that's why mostly in large samples we are then more concerned with the identification of these extraordinary large values or small values, also termed as outliers. So we have to focus on that. Now, as we know, that basically these are the concerns of spotting this normality factor. Then how to detect this normality here? So basically we know very well that we don't have access to the ideal distribution of the sample or even the population, so then we are only left with the factor that we have to test the observed data here in this case. So again, under the central limit theorem, as we discussed, if the sample size is greater than 30, then it is all right that the sample would be normally distributed, but again we have to look for abnormal values. So now how to go ahead with that? So we just went through the graphical displays, and we did go through the procedure of spotting these normality issues. And one is the PV plotting. Basically we went through the QQ plot, but PV plot or QQ plot both are the same in this case. And here we can see that in probability plotting it is very much essential that we have to draw the graph between the expected z values of the predictor variable and the observed values of z under z basically. So in this case here we can have a look on how to draw this PP plotting here, and under this case all what you have to do is go to analyze and go to descriptive statistics and go to PP plots. Now once we have clicked on that, we can select, for example, time spent revising, and we select it through the arrow here, and we have to basically click on the normal here, because we are testing for normal distribution, and here then we can click on OK. So here the PV plotting here, this basically straight line here is the expected z values, which should come in the form of a straight line, but obviously the z values which are calculated from the observed values of this data set are plotted. Now again, as we have discussed before, that these observed values should conform to these expected z values in this case. So here, as we can see, that basically the data values are farther from the main expected z value line. Here again, this PV plotting, as we discussed before, ideally what we did was that we just went to the descriptive analysis and we clicked on explore, and here you can see that we used to click on time spent revising, we used to select it, and then in plots part we just used to click on normality plots with tests. So this is one way to basically get the PV plotting, but you can also get the PP plotting from clicking on analyze option here, go to descriptive statistics and click on the PP plotting here. So here, as you can see, you can give any number of variables here in order to get the PP plotting here. Again, if you want to transform the data and then try to get the PP plotting, then you can transform the variable by taking, for example, the natural log transform, which is shown here. You can click on it, or you can transform the original data into standardized values. So you can transform them and then convert them into a different scale, so that the linearity or other properties of that specific data set can be adjusted. However, we will discuss in detail afterwards that why it should be followed and why it may not be advisable to follow this pattern. So here again, in this case, once we have gone through the PB values, so going back to our presentation here, in this case, the PV plotting we discussed before. We just went through how we can go through a different tool, and here again we have already gone through how to draw the histogram in this case. So now the other standard procedure of spotting the normality is to find out the values of skewness and kurtosis. We discussed in detail about that, and again, ideally these values should be equal to 0 in a normal distribution. However, mostly these values may fluctuate from 0 in this case, and sometimes we do have to convert them to z values by dividing these values with their relative standard deviation. So basically, in this case, we have already done that the values of skewness and kurtosis can easily be found out by clicking on Analyze button and go to Descriptive Statistics, and you can just click on Explore, or you can ask for the detailed descriptive factors by clicking on other descriptives option available in that case. We have already gone through that. So here basically then there is another way of trying to find out whether your sample is normally distributed or not. So here we have got two tests which comprise of Kolmogorov-Smirnov test, also termed as KS test here, and Shapiro-Wilk test here. Now basically these tests try to find out whether the sample data set is following normal distribution or not. And then again the indication for that is that if the values are termed to be significant, or in other words, I would say, if the test results are termed as significant, then that means that you have got an abnormal data, you have got a non-normal data. But if your test results are non-significant, then that means we are following normal data in this case. So let's have a look about how to go through these tests in SPSS. So let's go back to our data set in which we had to find out the relationship between exam performance of students and the anxiety level before the exam. And also we have a third variable related to the time spent on their exam preparation. Now here going to the analyze part, and we can go to descriptive statistics here, and we can click on explore. We can select the various variables. For example, I am testing exam performance and exam anxiety here, and going to the plots part, here there is an option which terms as normality plots with tests. Now we did use this option to find out the normality plots, but it also gives us results regarding the normality tests which are provided. So normality plots option can be selected from this menu, and by clicking on it we can then click on continue and we click on OK. So here again we are given before other descriptive statistics, we are also given tests of normality which can be seen on the screen here. Now here we can see that for exam performance the KS test is shown to be significant, and Shapiro-Wilk test is also shown here to be significant. Now again in this case there is one discrepancy here basically in these tests of normality, that larger is the test the sample size, then basically the larger is the chance that these two tests would prove significant, which on the other hand may be portraying not the clear picture of normality in this case. That's why it's important that you would have to look on your box plotting of this data. You would also have to look on the frequency distribution and histogram, and also the PV plotting, because relying wholly solely on these tests of normality is not advisable. However, these tests do give more accurate reading if the sample size is small, and mostly if it is smaller than 30, so these tests give us more effective reading. So here basically in this case you can see that our KS test statistic and Shapiro both negate the fact that the data set can be normal. However, on the other hand, if we have a look at the other figures, then they may prove contrary. So that's why it's very important that all the relevant measures to test the normality of the data must be used. So here the test of normality here, as we have discussed before, it's ideal for smaller samples. In larger samples there is more chance of error. So going back to our fact, here what we were basically looking about was the KS test and Shapiro test application, and then we have got another issue, and that is normality within groups, because it's not simply enough that you try the normality test on the whole data set, because normally if your data set is divided into many subgroups, then it is important that we should test the normality factor within those subgroups. So in order to do that, we have the facility of splitting the file, and in that case all what we have to do is go to SPSS. Let's say here we are dealing with two groups. One is in case of gender, basically one is male and the second is female. So based on that we would have to see whether a normality exists within these two groups also. So here what we have to do is go to data and click on split file option, which is given here. Now here you can see that we are given by default, the option is selected, analyze all cases, do not create groups. So in this case we have mentioned to SPSS not to create any groups, but if we do want to create it, then we have to click on organize output by groups here, and then we have to mention the variable based on which these groups would be made. So here, let's say I just want to make the groups based on gender, and I click on this arrow to select this variable. Now again, I would have to just click on OK, and now basically, as you can see here, the cases have been sorted by gender, and we just go back to the data set here and click on Analyze, and let's say we want to have descriptive statistics, and we want to have let's say we click on descriptives, or we can simply click on, in fact, in this case, PP plotting. We just want to compare the PP plotting of one variable in terms of these two groups. So I just click on OK, and as you can see that for male gender, a separate summary has been made, and a PV plotting has been created for male gender separately. Likewise, for female, all the details have been generated separately in this case. So we can also get the other details of descriptive statistics based on this group. We just click on descriptive statistics and we click on explore, and let's say we want to have the details of these two variables based on that group. So I click on plots. I have already clicked on normality plots with tests. I want to say, let's say I want to have histogram also, so I click on it and I click on continue. So clicking on OK, this would give us the exploration of data from both perspective, from male and from for female as well. So here this is one advantage of splitting the file into groups and then testing the various assumptions of each group by using the split file command. But here, yes, this is necessary, that in order to ensure the normality of data, it is not just important that we just basically try to test this data as a whole for the assumptions which we discussed before, but in fact we would have to test those assumptions in the subgroups which are existing in that data set as well. So here we have just displayed how to use the basically group data, and here you can see in case of female again the value for exam performance in case test is significant but non-significant in Shapiro. So again basically what we have to do is do keep the record of those tests for your analysis part, but you would have to see the other basically analysis techniques to test the normal distribution of this data as well, which would comprise of histogram and other necessary tools here. So once you have gone through that, let's come back to the normality within groups, and then we are basically dealing with this another technique which is basically used to check the linearity and homoscedasticity as well. We will discuss this homoscedasticity in detail in at the further end of this lecture. Basically what we do here is that we standardize the errors or the residuals which as just seen, and we plot them against the predicted values under the model, and we standardize them as well, and then we try to see whether there is some pattern emerging, and if there is some pattern emerging, then the data is not only not linear but also it doesn't have homoscedasticity. So basically this kind of tool is very much effective in giving us results regarding two major assumptions. We will do this in detail in the next slides. So here basically what is homoscedasticity, and in other words homogeneity of variance. So basically here under this condition, basically no matter how much samples we take out of the population, they should have around about same variance. In other words, this variance of this outcome variable should be stable at all levels. So basically we are not trying to say that the predictor value or the predictable variable value should remain same. Definitely the predictor variable value would keep on changing with respect to the changing data or with respect to changing independent variables data. But the point is that the main variance should remain the same. The fluctuation of data should remain the same. So that's how one of the condition which is stated under homogeneity of variance here. So here we are just seeing an example here, and in this you can easily see that basically in this case you can see that the trend is going up here in this graph. However, the values of the dependent variable are different, but the spread of the data, which is like this, basically in this form, is the same around each value which is being portrayed here and which gives us a dependent variable value. So the spread of the data around that specific relationship and around that specific value or concentration of values, and the spread of data remains around about the same in each reading. So that's what is important here. Likewise, in the other graph you can see that here the data spread and the data spread in the other shifting variables is around about the same. So that basically figure does tell us that homogeneity of variance is there in this data set. However, it is important to get a numerical figure which can be got from Hartley's test, and or in other words we can say we can calculate it through variance ratio. So basically why is this important that we should ensure the homogeneity of variance? Basically under this condition, the data which can be affected due to abnormal values here is basically related to the parameters of variables here, and then again the null hypothesis of significance testing is deeply affected by the abnormality in homogeneity of variance. So that's why it is important that variance homogeneity should be ensured over all data set in this case. So that's why it's very important that this homogeneity of variance is ensured, and we have to basically ensure this because of the fact that null hypothesis can be deeply affected by the abnormality in homogeneity of variance here. So now basically how to test for homogeneity of variance here, and basically we have got two options here in this case, and one is we can get it through graphs, and you we will get it in detail in our further lectures on regression, and in that I would give a detailed graphical overview of how to test this homogeneity of variance. So it's important that you have a look on these lectures, which we would have in future on regression also. So one way is that way. The other way is to go for Levene's test, and basically again it tests whether the variance in different groups of data are the same or not. Again, if the value is significant, which is reported under this test, then that means that variances are not equal. But if it is non-significant, then that means that variances are equal in this case. The other way of finding this homogeneity is to calculate the variance ratio, and here in variance ratio we just divide the largest variance with the smallest variance of the data set. Now if this value obtained is less than 2, then we can say that homogeneity can be assumed. So basically these are the few ways, and let's have a look about how to basically obtain this value through SPSS. So here we can just go to the Analyze button, and we click on Descriptive Statistics here, and let's have a look at frequency here. So here let's have a look whether we are given the option for Levene test or not. We are not given in this option, so let's go to Analyze again, go to Descriptive Statistics, and click on Descriptives here. So again, under that option we are not given the option to get that, so click on Analyze again, go to Descriptive Statistics and click on Explore. Now here let's say we select exam performance and exam anxiety. We do want to know about the result of the Levene test here, so we would just click on first statistics. We don't need any other statistical value, so we click on continue. So we click on plots here, and here there's one option which is stating spread versus level with Levene test. So here is one option here which we can click on in order to get the spread versus level with Levene test here, though we would have to select one variable here in this case. So basically let's see. So first what we have to do is basically go to the data part and click on split file again. We have to undo the change which we made previously. We click on Analyze All Cases and click on OK. Then again we click on Analyze and go to Descriptive Statistics here. So once we have clicked on that, we can then select Explore, and again here we can see there are two variables. So let's try to find the values regarding the groups. So we click on gender and include it in factor list, because based on gender, again these both variables would be separated. You can use this option, or you can also use the data split file option. It's your choice in this case. So by clicking on plots here, we can ask for the Levene test, and here you can see in Levene test the first option is none, then second is power estimation, and then third is transformed, and fourth is untransformed. So we can make the test on untransformed data, as we don't want to make any changes here. But you have the option to transform the data in case the data has been found to be non-linear, and we can transform the whole data set by taking the natural logarithm or square root or reciprocal. It's up to you that which tool you want to use in order to get your data basically normalized here. So here, let's say we want to have it untransformed. We click on continue, and then we click on OK. So rolling it down would give us basically test of homogeneity of variance, and in this case we are given the various Levine statistics based on mean, median, and also based on trimmed mean. So here we can see that basically nearly in all the tests, these tests are non-significant in terms of exam performance, which means that there is homogeneity of variance here. So basically again, homogeneity of variance would vary to vary basically depending upon the sample size. So in this way we can get a numerical figure regarding the Levine test, and this is helpful in getting us know whether our assumptions are being satisfied or not. So once we have gone through this Levine test option, again this must be kept in mind that Levine test may not give us again the accurate picture of the data set, and that's why we use other means to ensure whether there is homogeneity of variance or not. And under this option we have got an initial additional mean, and that is basically called variance ratio. And here you can see here basically the variance ratio is displayed here, with basically in this case with it is tested for 2 or more groups, and then again basically you can see that VR, or variance ratio, is calculated by taking by dividing the smallest variance with larger variance, as shown here. So this is the variance ratio, and if this variance ratio is less than 2, then we can assume that homogeneity can be assumed. But again there is additional way of finding out the homogeneity of variance, which is through graphs, which we will follow up in our further lectures on regression here. So basically this homogeneity of variance is of importance here because of the fact that this can affect your null hypothesis acceptance. Now coming to the next option, that's called independence, and again we assume that the errors in our model should not be related to each other, and again if this assumption is violated, then we would have serious problem regarding the significant test in this case, which will no longer be valid. So now how to reduce this bias, how to basically ensure that this problem does not arise regarding the distribution of data. So first treatment is you trim the data, like you just delete the extreme values in this case, which may be termed as outliers. But here you would have to do that only when the theory allows you to do that, because sometimes your theory in which you do want to test does not allow the deletion of scores in this case. So that's why in this case we are very cautious while trimming the data. So again in this case we should have basically past data which has followed the same procedure. Now once we are given and once we have to delete these scores from the extreme, one option which basically SPSS does give us is in the form of a trimmed mean, in which 5% mean is trimmed. We will discuss it in the next slide in detail. Then the second option for reducing the bias is windsorizing, and in this case we substitute the outliers with the highest value in data available, which is the highest value, but then it is not the outlier in this case. So this is one way to do that. Then the other most robust method which is used is termed as bootstrapping, and finally we are dealing with the transformation of data by using a mathematical function to all the scores in all the variables. In windsorizing, basically this substitution of outliers, however, should be done while keeping in view the relevant theory which you are following, and whether replacing the extreme value with the highest value would affect your relationship which you want to test or not. So both of these options of using the trimmed data and windsorizing basically is dependent upon the theory which you are following, the relationship which you want to test, and also the way you want to test the whole data. So the third method here is related to the bootstrapping, and bootstrapping basically is related to the fact that we basically do not have any idea of the original distribution of the population or even sampling distribution. So here what we do in bootstrapping is that the software automatically takes many samples, subsamples out of the main sample which you have taken from the population, and not only it takes sample, but also it replaces the sample from the main sample which has been taken, and it basically calculates all the mean statistics involved in that, and then again based on the other sample drawn from the main sample, it calculates the same values again. So it repeats this procedure like around about 2,000 or 3,000 times, and based on that data set we have got some certain figures which do give us some idea of the distribution which population might have. So bootstrapping basically is that methodology followed. Fourth methodology is related to the data transformation, and in that we have to basically apply some kind of mathematical function to basically adjust the scores. Now here basically let's go to the details of that. First is regarding the trimming of data, and here we can see a practical example. Here in this case, basically as you can see, first the data has been ordered, and then here you can see that the mean basically was trimmed at 5%, and again it was trimmed at 10% also, then it was trimmed at 20% also in this case. So basically these are the various options available under which we can trim the data to our needs here. So basically when we use the explore command, we do get the option basically of getting the trimmed mean, as you can see in basic or SPSS analysis. if we, let's say, try to explore the one variable by clicking on Analyze and clicking on Explore, and let's say just return this gender list, and we go to statistics part, and then we click on continue, and we let's say click on OK. So here we can see that the data basically which has been basically presented here is regarding two variables, exam performance and exam anxiety, and here you can see the mean has been trimmed to 5%, but this is the option which SPSS uses by default, and in order to do additional trimming, it is advisable that you basically do it on manual basis. So here in this case, the mean reported would be trimmed by default here. So coming to the main method here, the trimming of data is done basically in most cases, and then coming to the data transformation, here you can see there's one additional option of transforming the data, or basically converting the data. Now in this case, basically you can see the log transformation factor, which can be used. We can just take the log, and once we take the log, it can be used to reduce the positive skewness. This is one basically method to transform the data and use it more effectively. Then is the one basically important factor of taking the square root transformation. It also reduces the positive skewness and can also be useful for stabilizing the variance as well. Then the other way is taking the reciprocal transformation. You can do that by taking the reciprocal. However, all of these transformation options can be used by clicking on transform variable and clicking on compute. Now here, for example, we can go to SPSS, and we can click on transform, and then we can click on compute variable option, and then we can see here that basically this time spent revising, we just want to take the square root of that, so we click on all function group, and we can choose the square root, so we can go to S, and here you can see in this option, under the functions and special variable, we can click on SQRT, and we can select it through this arrow, and then we can click on the time spent revising, and we can select it. This variable is then selected, and once we give the target variable name and clicking on OK would give us the computation of that variable. As you know, we have gone through this exercise before. So based on that, also we can go through this additional option, as you can see in Descriptive Statistics, and going through the Explore part. If we go to the Plots option, you can see that spread versus level with Levine test can be additionally used. Let's see, first we have to indicate the factor list variable also here in this case, so let's click on that and then click plot here. So here, as we said before, for example, we want to test the Levine and we want to carry out the Levine test, so we can do it on transformed variable, and here you can see the power, we can take the natural log, we can take the square root and the reciprocal and the square or cube as well, but it depends upon you. So instead of first transforming these variables through compute variable option and then again clicking on transforming them and then again clicking on exploring the plots, we would have more time taken in this case. So in order to save the time, we can just click on transformed option in this Levine test case, and then we can use these various options to test get the test results from these transformed data variables. So these are the various options through which you can basically get the results from the data, and you can reduce your test biasness, you can reduce basically the abnormality of your data. So abnormality of data through these four basic procedures can be used here as discussed. But again, there are, as we would discuss ahead, there are issues regarding data transformation as well. So this was related to the lecture we presented and we discussed here now. So in today's lecture, basically we discussed about the various assumptions which are very critical before testing the hypothesis. Otherwise, if they are abnormal, they would deeply affect our testing of hypothesis in this case. So we discussed about the additivity and linearity here in this case, and then we discussed about how to proceed with the normality, how to ensure that we should have normal data, and then how to ensure that there would be homogeneity of variance in this case. Likewise, how to treat this, how to test this, and we also went through how to ensure the independence of data in this case. The data independence factor would be discussed in detail also in future cases. And then we had a brief overview of the tests, how we can run the tests, how the basically biasnesses which are existing in the data can be reduced, and how can we deploy different methods to reduce that biasness, which do include like the trim mean option, and in this case again we have got windsurring, then we have got other important factors as well, which include data transformation, and there are various issues involved in data transformation as well, which we will discuss in the next lecture. So this was related to the present lecture here. Thank you so much. Allah Hafiz.